This lesson is on an introduction to functions. A relation is a set of pairs of inputs and output values. You can write them as an ordered pair. When we're writing an ordered pair, it's always going to be the x value that comes first and then the y value that comes second. The x value is also considered to be the input. The y value is considered to be the output. The domain of a relation is a set of all the inputs or the x-coordinates of the ordered pair. The range is a set of all outputs or y-coordinates of the ordered pair. A function is a relation in which each element of the domain is paired with exactly one element in the range. So that means that each x value has only one y value. And a relation or a function can be discrete or continuous. Discrete just means it's chopped up, so not all numbers are going to be considered to be in the domain or the range. Continuous just means it's non-stop, so there'll be all of the numbers that can be decimal values as well. Task 1. Are the following relations functions? State why or why not, then state the domain and the range. So for A, we notice that the input of 3 has two different outputs. So 3 goes to 1 and 3 goes to 3. So this relation is not a function. Now to state the domain and the range, we're just going to list what we have there. So the domain is the x values or the inputs. In this case, those numbers are 3, -2, and 1. If a number repeats, we don't have to write it twice. The range is the y values, which is 1, 4, 3, and 0. It's better to write them in numerical order, so our domain would be -2, 1, and 3. Our range is 0, 1, 3, and 4. For B, each input or each x value only goes to one y value. So none of the inputs repeat, so this would be a function. Our domain would be all the x values in numerical order. So it would be -3, 2, 5, and 8. Our range is all of the y values, which is 1, I'm going to write in numerical order, -7, 1, and 5. And it's okay that the range repeats, just as long as the domain has one range value. Task 2, same thing. Identify the domain and range, tell whether it's a function. So the domain is the x values, or the inputs, which is -3, 1, and 4. Our range is -2, 1, 3, and 4, because those are our output values. I noticed that 1 in the input has two different outputs, so that means that this first relation is not a function. For our second one, the domain is all the inputs, which is -3, 1, 3, and 4. and the range is all of the outputs, which is -2, 1, and 3. Since each input has one output, this relation would be a function. Determine whether each relation is a function, then state the domain and the range. So for the first one, each x value has one y value, so this would be a function. The domain, since we have arrows on the end, it's continuously going to the left and the right, so the domain would be from -infinity to infinity. The range talks about how high and how low it goes. Since they're arrows, it's continuous, going on forever, so it's also going from -infinity to infinity. For the second one, I notice when x is, say, 1, there are 2 y values here. So this would not be a function. The domain, how far left to how far right, this is the endpoint on the left, this is the endpoint on the right. So our domain is going from 2 to 2, and we would have a square bracket because they're included. The range, how low to how high it's going from the same numbers, -2 to 2. The third one, each x value has one y value, so this would be a function. For the domain, since it has arrows on each end, it's continuously going to the left and the right, so our domain is -infinity to infinity. The range, the low point is 0, and the high point is infinity because it continuously goes up forever. We have function f, that's f of x equals 2x minus 4, has the domain from 2 to 6. We want to know what the range is. So the range, we're going to pick the low domain value of 2. So that would be 2 times 2 minus 4, 4 minus 4, which is 0. Then we're going to pick the high value for the x, which is 6, and we're going to do 2 times 6 minus 4. 12 minus 4 is 8, so that means our range is going from 0 to 8, which would be answer choice 1. And one way to determine if a graph is a function is if it passes the vertical line test. The vertical line test states that a relation is a function if and only if no vertical line intersects the graph at more than one point. If it passes through 2 or more points, then it is not a function. So if we have an example like we had before with our circle, here's my graph. If I draw a vertical line, it touches my graph twice, so this would not be a function.